Now, we can talk now about structural isomerism. For a given molecular formula, there are maybe different ways of arranging the atoms. A molecule with the same molecular formula but different structural formula as another molecules we can call the structural isomer. For example, C5H12O has structural isomers such as CH3, CH2, 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 CH2OH, or CH3CH OH, CH2, CH2, CH3. Or we have like probability of connection between isomerism. Structural isomers have the same molecular weight. Look at all these compounds. It is consists of same isomeric structure or same molecular formula, but different structural formula. What that mean? We have three types of structural types or the structural isomerism. First one, positional isomerism. Second, functional isomerism. Third, chain isomerism. First one, in a positional isomerism, the position of the function group function with each isomer. For example, with molecular formula C3H6Br2, we can form the following position isomers. First function, it is our first isomer suggestion. Isomers, we have two atoms of bromide, that's in atoms number 1 of carbon and atom number 2 of carbon. And the other suggestion or possibility isomerism, we have in connection of bromides in a first atom of carbons and the third one. All of these, they give us or they give the name different of the other, depends on the position of bromide. We have now four possibilities of this bromide. Third one, bromide in the first carbon atoms, that connections in both sides. And the other we have in the middle of carbon, or in the carbon number 2. When drawing the possible position isomers of molecule formula, we must take care not to draw the same structure twice. For example, we can do same this model for the isomerism. There is a free rotation around carbon covalent carbon or single bonds. Therefore, drawing different functional groups across different sides of the drawing may not always result in different structures. Look at this. We have a bromide in the carbon connect with the carbon number 1 and the carbon number 2. It's the same with the bromide in carbon number 2 and carbon number 1. while in the last one is connection between bromide and carbon atoms in the first molecule or first atom and the second atom. We can do a possibility of connection. For example, we have three molecules of carbon. And here, hydrogen, hydrogen and bromide. Here, bromide and hydrogen. Look at the different bromide. Look at all the overlap between the bromide when it is transferred from the first atom to the second atom with the different position. Sorry. Look at here. Last one. Look, all of these this belong about possibilities of isomerism. That's mean of isomerism that choose a different position of the active atoms in this compound, and we can see how is difference in their name or their effective.